All right, we are going to get started on section 7.1, multiplying and dividing rational functions. Rational functions are just functions, or a rational expression in general, is just a ratio of two polynomial expressions. When you hear the word rational, you can sort of think fraction, okay? So let's go ahead and get started here. Let's start with just fractions, okay? So it's just how would we simplify a fraction that was like 15 over 65? Well, the first thing that we would do is we would factor the top and the bottom and see if there's any common factors between the numerator and the denominator. 15 factors into 5 and 3, and 65 factors into 13 and 5. And so when we factor those, what we see is that 5 over 5 simplifies to 1 over 1. So this entire fraction simplifies to just 13 over, 3 over 13. All right, let's go on to the next one. So that we can use that method to scale up to more complicated fractions. So if I have 3x cubed over 6yx to the fourth, I can again look for common factors. I'll start with the fractions. So the fractions, and I can zoom in a little bit here so you can see a little bit better. The fractions, I'll start with the constants, I should say. So I have 3, that doesn't factor any further. 6, though, breaks into 3 times 2. So I'm going to factor the bottom into 3 times 2yx to the fourth. And then what I see is 3 over 3, that's 1 over 1. I still have a 2 on the bottom. And then the x cubed over x to the fourth, well, there's 3 x's up here that will simplify to 1 with 3 of the x's down here, so I will end up with just x to the 1 power on the bottom. And so I finish this out with just x to the, just 1 on top, actually. Sorry. Off to a good start here. Just 1 on top, because this is 1 over 1, and this is I'm going to simplify to 1 over 1. So 1 on top, and then 2y x on the bottom. I can take this further. I can apply it to this problem where the top and the bottom are factored quadratics, or at least the bottom is a factored quadratic. And I can see here that I have x plus 3 over x plus 3. That simplifies to 1 over 1. So I end up with just 4 over x minus 5. Now I should say that this only works if we are multiplying factors on top. For instance, if I had 4 plus x plus 3 over x minus 5 times x plus 3, I would not be able to break that up in the same way. We'll talk more about why that is in class, but for right now, that would not just assume that that would not simplify. Okay. Next, sometimes they won't be kind of nicely factored, these rational expressions. So we will have to do the factoring. So I have x squared minus 2x minus 15 on top and x squared minus 9 on the bottom. If I want to factor those, I can do two things. I can either use the magic x method on each one, which will work fine, or I can just sort of use my reasoning and guess and check to figure out what they factor into. On top, I need numbers that multiply to give me negative 15 and combine to give me negative 2. That is going to be 5 and 3, x and x, and it'd be minus 5 plus 3. On the bottom, that's a difference of squares, so this is going to break into x minus 3 and x plus 3. Again, you can use the magic x method if you'd like as well. X plus 3 over x plus 3 simplifies to 1, and I'm left with just x minus 5 over x minus 3. When is this function undefined? Well, it's undefined whenever the denominator is 0. Okay, any number that you plug into the denominator that makes it 0 is undefined, because you cannot divide by 0. A number divided by 0 is nonsensical. So we'll write that at x equals 3 and x equals negative 3. That's where the function is undefined. Or I guess we should write this. Let's write this. X cannot be 3 and x cannot be negative 3. Okay? Yes, we take the original, not the simplified version, because we're asking about the original. Moving on to this one. You should try this one, by the way, and see how it goes. The top quadratic breaks into x plus 1 and x plus 3. The bottom breaks into, so x minus 6 doesn't change. And then over here we have x minus 3 and x plus 3 again. Simplify. Those go to 1. I've got 5x, x plus 1, and x minus 6, and x minus 3. Nothing else changes, so that's all I end up with is just that. It is undefined at x. X can't be 6, x can't be negative 3, and x can't be 3. Okay, so I ran out of space, but this is be your final simplified answer there. Okay, let's talk about factoring out a monomial. So in all of these, I should have checked for a monomial first. In this one, it looks like a monomial was already factored out. That's just a one-term polynomial that shows up in every term in the numerator. So for instance, if I look here, notice that there is a z in each term in the numerator. So I'm going to factor a z out in front, and I'll get this z. And then left over will be x minus 4. This is all going to be divided by z squared times 4 minus x. All right. Now, z to the 1 over z squared, one of these z's is going to simplify. I'll be left with just z to the 1. So I get x minus 4 over z times 4 minus x. These are not quite the same. Okay, so they do not simplify. So we'll just leave our answer there. All right, now let's talk about multiplying and dividing rational expressions here. So when I multiply fractions, if I have something like, 1/2 times 4/5, I multiply straight across the top and straight across the bottom. So I'll get 4 over 10. And then that fraction could be simplified further, right? That ends up being 2/5. The same is true for rational expressions. So I can take and multiply these straight across the top and straight across the bottom. When I do that, I'll get 90 c squared, c times c is c squared, d squared, divided by 40 dA. And then 90 over 40 is going to simplify to 9 over 4. You can use a calculator to help you simplify these fractions, or you can do it the old-fashioned way and factor them and simplify. But that'll simplify to 9 over 4. I've got d squared over d, so that d is going to simplify to 1, and we'll have just 1d left on top. And then the c squared and the a won't change, so I'll be left with 9 c squared d over 4a. Next one, division. So for division, we are going to turn every division problem, division of fractions problem, into a multiplication problem. When you divide a fraction, that is the same as multiplying by the reciprocal. So if I have, 2/5 divided by 1/2, that is the same as 2/5 times 2 over 1. I'm sorry, so you can see that. Okay, 2/5 times 2 over 1. You flip it. You multiply by the reciprocal. That means to flip the fraction is what the reciprocal is. Okay, so this problem here, we're trying to solve this. The first thing that we're going to do is turn it into a multiplication problem. So 18xy cubed divided by 7a squared b squared times 35a squared b divided by 12x squared y. All right. So then you've got a couple of ways that you can do this. Probably the easiest way is just to multiply everything across the top. So we have 18 times 35, and I'll even show you on the calculator how to do this easily. So we have 18 times 35, that's 630. Then we have x, y squared, a squared, b. The bottom, we have 7 times 12, that's 84. I have a squared, b squared, x squared, y. A squared, b squared, x squared, y. And because all of these are being multiplied, I can now look for common factors in the top and the bottom and simplify accordingly. So I have a squared over a squared, that's 1 over 1. I have x over x squared, so that's going to be gone, and then this will be to the 1 power. I have y squared over y, so that y is gone, and this will be to the 1 power. And b over b squared, that b is gone. This will be to the 1 power. And so I can rewrite that. So, and then I can simplify the fraction. So in my calculator, I'm going to do this in Desmos as well. If you just type in 630 divided by 84, you get 7.5. And on this calculator, it would be math fraction, and you get 15 over 2. 7.5 is fine for an answer as well, but the fraction is nice because it stays in the form of the rational expression. So I can write 15 on top, 2 on the bottom. On top, I have a y to the 1 power, and that's it. I'm sorry, I copied something down wrong here. This should be to the third, y to the 3rd power, so there should be a y squared there. My bad. Okay, so 15 y squared, and then 2x to the 1 and b to the 1 on the denominator. Okay. All right, last one on this page and last one for this part of the video. We are going to take and factor everything here and then see what simplifies. So this quadratic on top is going to break into numbers that multiply to give me negative 16 and combine to give me negative 6. That's going to be 8 and 2. It's going to have to be minus 8 and plus 2 to get that. And then this x minus 8, I'm just going to carry that down. X minus 8, because I'm multiplying fractions, so I'll multiply straight across the top and the bottom. This quadratic here is going to break into x minus 8 and x minus 8. This quadratic here will break into x plus 3 and x plus 2. And so I have x plus 2 over x plus 2 simplifies to 1. I have an x minus 8 over an x minus 8, those simplify to 1. An x minus 8 over an x minus 8 simplifies to 1, and I'm left with just x plus 3 in the denominator. So, because everything on top simplified to 1, I just have 1, and then x plus 3 in the denominator. Right? And that's it for that one. So that is going to round out our part 1 of the video here, and then we will go, we'll put part 2 in a second chunk.